Yeah. Now we'll move on to your different types of relaying mechanisms. So in the last session, we have seen about the data acquisition module where the data have been acquired. Now the data is acquired has to be transmitted, right? So this is facilitated by using this fiber optic mechanism and microwave mechanism. So in the third unit itself, we have learned the general method of relaying, that is your carrier current protection. But whereas this fiber optic relaying and microwave relaying is the advanced option. Now let us see the components of the fiber optic relay. Like it consists of a fiber optic transmitter and the data has to be transmitted via optical fiber. Then for receiving it, you have an optical fiber. Since the data is going to be sent over long distances, you have an optical regenerator, which is nothing but a signal conditioning circuit. Now we'll just see what is the function of a transmitter. So it just produces and encodes the light signal. So the encoding part is going to be carried on by means of your optimal transmitter. Now the data, that is this optical fiber, is going to conduct the light signals over a long distance. Since it moves over a long distance, this optical regenerator is going to boost the degraded signals which is transversed via a long distance, and optical receiver at the final where it is going to receive and decode the light signal. So the transmitter encodes the light signal, whereas it is going to be decoded into electrical signal by means of a optical receiver. Now we'll see the detailed setup of the fiber optic relays. So the transmitter, it receives a signal which has to be transmitted, and it instructs the optical device to turn on the light or turn off the light in a proper sequence. Okay. So this transmitter will consist of a lens so as to focus the signals onto the optical fiber. So usually if you see, you can have both lasers or LEDs. Okay, so but we'll be widely using lasers because so it can handle more power handling capacity, but the drawback is that it varies with respect to temperature and it's quite expensive. So the usually common used wavelengths of the light signals used in this fiber optic relaying are 850 nanometers, 1300 nanometers and 1550 nanometers. So which usually falls in the non-visible portions of the spectrum. Now we'll move on to your optical fiber. It is nothing but it is going to be a transparent flexible filament, so which is going to transfer the data from your transmitter to your receiver. Okay, the data is going to be obtained or delivered at the receiver by using this optical fiber. So the next part of the fiber optic relaying is your optical regenerator. So as I told you already, the signal is going to transverse over a long distance. So whenever it is going to reach the receiver from the transmitter, the signal strength will not be as good as it has been sent from the transmitter. So there is a possibility of the signal loss in the circuit, right? Since it is going to be transversed over a long distance. So this optical fiber's main function is to boost the degraded light signals. It is nothing but a signal conditioning circuit. So or else you can say in other words as a laser amplifier for the incoming signal. So and here usually the distance mentioned here is 1.6 kilometers or even more, half than a mile. So in that case, so this optical regenerator is a must in the circuit so that the correct information is received at the receiver side. Now the optical receiver, it takes the incoming digital signals and it decodes into the electrical signals so that it can be used by the other users like computer or TV or telephone. So this thus the receiver, it will use a photocell or a photodiode to detect the light. Now we'll move on to the advantages of fiber optics. Of course, it is less expensive in the sense once you have installed, it will be remaining for years. And it is going to be a thin, lighter cable, and it is having the higher current carrying capacity and higher data carrying capacity and less signal degradation. less interference as compared with your electrical signal, and it requires low power. Now we'll see how the differential protection of the cables is going to take via other fiber optics, right? So this diagram shows that a differential relay has been put in your line. So what is the general principle of the differential relay? Differential relay is one which just compares the current from both the ends. Whenever the fault is going to occur, then in that case a differential current of I1 minus I2 will flow through the relay and the relay will act on. Okay, so it just compares the current from the both the ends. In case of a fault, there will be a differential current will flowing through the circuit, and under normal conditions, so the current at both the ends will be same. So the same concept is going to be followed. The only inclusion is that the fiber optic cables is going to be laid on the both the sides. That is, both the relays, they are going to communicate via a fiber optic link, which is going to be laid parallel to a power cable. Now we'll move on to the last topic of today's session, that is microwave relaying. So this microwave relaying is nothing but it establishes a point-to-point communication, and you're going to have the specific rated or your specific frequency or your bandwidth rated antennas both at the sending end as well as at the receiving end. Okay, because of this, the main advantage is that, so this is going to have it can carry a larger amount of data. So usually if you see the microwaves, they are used for in the range of 450 megahertz to 10,000 megahertz range. So the data carrying capability is more. And further, this microwave band, it has been observed that it has a bandwidth 30 times that of the rest of the radio spectrum. So it can handle huge lots of data, where in a place like India, where we have to take the cables across the buildings and country. Now, so as I told you, it consists of the antenna-centered reflective dishes, which is going to be attached to the towers or buildings. Okay, so it offers a good bandwidth in the range of 6 gigabyte per second. The only drawback in case of your microwave is that it is distance limited. That is, you can use it for the local data transfer, but the data signals cannot be transferred in case of across the hills. So mainly this microwave communication, it is used for the digital protection relaying, for communication purpose, for only to exchange the data, that is the local data. If I want to exchange a large amount of the data in your fiber optic communication, so this is widely used. Thank you, students. If you have any queries, post to me. Thank you.